Now we're going to look at what's called polynomial expressions. The numeric coefficient, usually called the coefficient, is the numeric factor, the sign, and the number in a term. The degree of a polynomial is the largest exponent that is in any one term, and the leading coefficient of a polynomial is the number with that particular term. To determine the number of terms of an algebraic expression, you identify the parts of the expression separated by plus or minus signs that are not inside grouping symbols. So in this particular expression here, my coefficients, I would have -5, 6, -7, and 2. Those are my numerical coefficients. The degree of the polynomial, well, that's the largest exponent you see. So the largest exponent you see here is the power of 3. So the degree of this polynomial is 3. The leading coefficient, the number with that particular factor, is a -5. Now, how many terms this expression has? This is my first term, second term, third term, fourth term. So there's 4 terms here. Now, terms such as 7 and 9, 5x and 3x, or 7ab and 4ab are called like terms. Like terms are numerical terms or variable terms whose variable factors are the same. So if you'll notice 7ab and 4ab, my variable factors here are ab. They have to be exactly the same. To add or subtract, called simplify like terms, you add and subtract the numerical coefficients and write the common variable factors. If grouping symbols are present, use the distributive property in order to simplify the expression completely. Now, terms such as 8x and 3ab are unlike terms because their variable factors are different. Also, the terms 9 and 7b are unlike terms because the 9 does not have a variable factor, whereas the 7 does. So expressions such as 8x plus 3ab and 7b minus 9 cannot be written in a simpler form. That's as far as they can go. So our first job on this particular problem is to combine like terms. Now you can rewrite the like terms together if you want, or scan through. I usually look at my first term and then scan through the problem to see if there's another x squared available. So I see 3x squared and a -9x squared, so that will give me a -6x squared. Gotta move it a little bit more. The next term I have, and mark these out as you go, so that way you'll know you've taken care of them all. 7x minus 2x would give me a 5x plus 5x, because when I go further into the problem, I've got to keep the sign. So these two are done. That's done, and that's done. The only thing I've got left is a -2 plus 5, so I should end up with a +3 at the end. So that's this expression simplified. Now this one, let's see. I've got a BC, here's another BC. So I've got a +3 minus 6, so that'd give me a -3 BC. So mark those out. The next term I have is an AD. I've got an AD here and back here. A -5 minus 7 will give me a -12 AD. And the only two I have left now is a +10 AC and a +12 AC, which will give me a +22 AC. So we have combined like terms. Now this is going to be fairly similar to this, but the only problem is I've got parentheses. I've got to get them out of the parentheses. Now in front of this parentheses it's understood to be a +1. So if I multiply +1 times all of these, I get those particular terms right back. But now this one I've got a -1. So if you distribute a -1 through, all signs change. So you've got to do that first. We've got to get them out of the parentheses. So see if I change. Now these should be the exact same. These should be completely different. A -9x squared plus 4xy minus 2y squared plus 1. So now we're back to collecting like terms. First one I have is a 5x squared. I've got another one here, so that will give me a -4x squared. see if I can see my square. The next term I see is an xy. So I see a plus 4xy, another plus 4xy, so it'd be a plus 8xy. Okay. I see a y squared. So I've got a negative 3 minus 2, so I'll have a negative 5y squared. Plus 2 plus 1 looks like it should give me a plus 3, and that should finish it up. Now you try the next one. Get rid of the parentheses first, pause me, and then go ahead and try and combine like terms. So a plus here, I rewrite these as is. Same thing here, but this one I'm going to change all signs. So let's see if I did that. Plus x squared plus y minus 4x plus 2y. And combine like terms. I see a 2x squared plus 6x squared plus x squared. That'll give me a plus 9x squared. Remember, if you do not see a coefficient, it's understood to be a 1 there. Next term I have to play with is an xy. I see no other xy's, so I just have a plus 12xy. I've got negative 11 plus 4 plus 2, so that would give me, what, a negative 5, I believe. So you should have marked that one, that one, that one, that one out. Oh, here's it. I didn't mark this out. I've got a negative 2x and a minus 4x. That would be a minus 6x. And they should all be marked out except for the y. So I should have just a plus y. And that's it. Now this polynomial multiplication, this uses our rules of exponents that we had earlier. We've got to remember how to do that. Now this is a monomial times a monomial. So I've got 13 times 3, that would be 39. X to the third times x squared would be x to the fifth. And y times y squared would be y to the third. So you see, you can group them together or just look for the particular pieces and use your rules. So now the distributive property. Now this was a monomial times a monomial. Well, now I've got a monomial times all of these terms, and that means I've got to distribute. I've got to do the 5bc times the 4b squared, 5bc times the negative 3bc, and the 5bc times the c squared. So let's go with the first one. 5bc times 4b squared. 5 times 4 is 20. b to the third c. A little bit more. Okay. So that first multiplication's done. Now do an arrow. I like to do arrows. Let me see if I can insert an arrow real quick. I don't know if I'm going to be able to get a nice arrow. Probably not. Let's see. If I do this one times this one, I guess I can do it that way. Weird, but it'll work. But I don't want to do that. See if I can pull it up a little bit more. Yes. Alright. So 5 times negative 3 is a negative 15. That will give me a b squared c squared. So negative 15 b squared c squared. A little bit more. Okay. And now let me elongate this one. See if I can. See, can I do that? Weird. Okay, so 5bc times c squared. 5 times 1 is 5, b, c to the third. So let's see if that's it. There it is. I wonder if there's a better arrow. Oh. Okay, so let's go 4/9 times 12z. So, depending on how good you're at fractions, it's whatever you want to do. You can do this by hand or via a calculator. Let's see, 3 will go into the 12 and the 9, so that should leave me with 16 thirds. Well, let's try it. 4 divided by 9 times the 12, and go frac it. I don't want any decimals. Yep, 16 thirds times z squared. Okay. Let me elongate my arrow. go to the next term. So 4/9 times 21. Let's see, you do it in your calculator. Let me see if I can do it. 3, 7, 28 thirds. So it'd be a plus 28 thirds z to the third. Okay, now you try the last one. 4/9 z times a negative 18z to the third. Pause me so you can go ahead and finish it. That should give you a negative 8z to the fourth. Come on. Yep. Let me get rid of my arrow. Okay. So it's polynomial multiplication. And that's it for this video. Thank you.